everyone, it's Miss Joyce. Today we'll be talking about benchmark fractions. Benchmark fractions include the numbers 0, 1/2, and 1. The purpose of benchmark fractions are to help assess the reasonableness of your answer, just like when we estimate quotients. So we are going to use fractions and decide if they're closer to 0, 1/2, or 1. Benchmark fractions can also help you compare fractions. So if a fraction is closer to 0 and the other fraction you're comparing is closer to 1, you know that the fraction that's closer to 1 is going to be the bigger fraction. Blank the fraction to help you determine which benchmark fraction your fraction is closest to. So to help us determine which one it's closest to, we can visualize the fraction or draw a picture of what that fraction looks like. Here we have 3 different glasses. In this first glass, we can see there's no water in it. It looks empty. This is going to be closest to 0. In our next glass, this looks like it's almost halfway full. It might not be exact, but it's close to halfway. So this would be closer to the benchmark fraction 1/2. And in the last fraction, it is filled a lot more with water. It is almost filled to the top. So that means this represents a fraction that's closest to 1. In the table, we're going to create a visual model and label the benchmark fraction that each given fraction is closest to. Then we'll circle the smallest fraction and put a square around the largest fraction. The first row is done for us. They give us 4/10, so that means we're going to create a model, and it's broken up into 10 equal parts. We're shading 4 of those parts since the numerator is 4. We have this line here down the middle to show where that halfway mark point is. So since there are 10 parts, halfway would be 5. So we put a line after the 5th part to show where halfway would be. We can see in our shaded parts, we are only 1 part away from the halfway point. So that means this fraction is closer to the benchmark fraction 1/2. Let's try the same thing here with 5/6. We'll create a model and break it up into 6 parts. We're going to shade 5 of those parts because the numerator is 5. Let's find that halfway point. So if there are 6 parts, halfway would be after the 3rd part. Well, we can see that there are 5 parts shaded, which is only 1 part away from having the entire model shaded. So this fraction, 5/6, is closest to the benchmark fraction 1. For 2/8, we're going to draw a model that has 8 equal parts, and we're shading 2 of them since the numerator is 2. Let's find the halfway mark. So if there's 8 parts, halfway would be after the 4th part. So we draw the line here. We can see that there are 2 parts shaded. Well, that's interesting because that means that 0 right here, it's 2 parts away from being 0 or none of it shaded. But it's also 2 parts away from being halfway shaded. So this is right in between the 2 benchmark fractions, 0 or 1/2. Either of those responses would be fine. The smallest fraction here, we are going to put a circle around it. Well, if we look at these visual models and we look at our benchmark fractions, we can see that there's only one fraction that could be closest to 0, and that would be 2/8. So we're putting a circle around 2/8. Now we're going to find the biggest fraction. Well, if we look at our visual models and our benchmark fractions, we can see there's only one fraction that's closest to 1, and that would be 5/6. Now let's try 5/8. First, we'll create a visual model that has 8 equal parts, and 5 of them are shaded. Let's draw a line at that halfway mark. So half of 8 is 4, so we'll draw a line after the 4th part. We can see in this visual model that we have 1 part that's shaded after the halfway mark, but 3 more parts need to be shaded to get to the 1 whole mark. So 5/8 is closest to 1/2. Now we have 3/9. So we're going to create a visual model that has 9 equal parts and 3 of them are shaded. Well, the halfway mark is actually going to be in between one of these parts. So we're going to break up this part here right in the middle and draw a line right through it. We can see that the three parts are shaded past the 0 benchmark, but only 1.5 more parts need to be shaded to get to the halfway mark. So 3/9 is closest to 1/2. Now we have 1/3. So in the visual model, we'll have 3 equal parts with one of them shaded. Once again, we're going to find that halfway mark, which is going to be in between the second part. We can see that there's one part that's shaded past 0, but we only need half of a part more shaded to get to the halfway mark. So 1/3 is closest to 1/2. Notice with these two fractions, we have the same part of the whole shaded. So if we look, the same amount of the entire whole is shaded, even though in 3/9 there are more parts shaded, each part is smaller. So since the same amount of the entire whole is shaded, 3/9 and 1/3 are equivalent fractions. Finally, we have 1 and 1/6. We're going to create a visual model that has one whole entirely shaded and 1/6 of another whole shaded. We're trying to see which benchmark fraction 1 and 1/6 is closest to. Well, half of the denominator 6 is 3, so we'll draw the halfway mark after the third part. We can see that we are just one part over one whole, but 2 parts away from 1.5. So 1 and 1/6 is closest to 1 whole. Now let's go ahead and find the smallest fraction here. Well, we have 3 fractions that are closest to the benchmark 1/2, and one fraction that's closest to the benchmark 1. So we want to look and focus on these 1/2 benchmark fractions. If we look at the visual models, we can see that 5/8 is actually a little bit bigger than 1/2, but 3/9 and 1/3 are less than 1/2. So we know that 3/9 or 1/3 is going to be our smallest fraction. So let's focus on those two. Well, we already said that the same amount of the whole is shaded in both of these fractions. These two fractions are equivalent. So 3/9 and 1/3 are both the smallest fractions. So we can circle both 3/9 and 1/3. Now let's find the largest fraction. Well, if we look at our benchmark fractions, there's only one benchmark fraction that's closest to 1. So that means that 1 and 1/6 is going to be our largest fraction. What strategies did you use to determine which benchmark fraction each given fraction was closest to? Well, we can use visual models to determine which benchmark fraction each fraction is closest to. Those visual models help us see if our fractions are closer to 0, 1/2, or 1. Why did you place 1/3 in the column that you did? After finding the halfway point, we found that 1/3 is slightly closer to 1/2 than it is to 0. That's why those visual models will really help us determine which benchmark fraction each of the given fractions is closest to.